Hi, welcome. In this video, we will solve problem merge to sorted linked list asked by companies like Amazon, Microsoft, Facebook, Google, and some others.
Now let's check out one another problem on linked list. So we first two sorted list. Okay. So two sorted lists are given. Okay. Let's see. Again, this is a fundamental, quite fundamental problem. Usually asked in the interviews. Okay. So if you are going for an interview where linked list can be the part of it. So yes, this can be one of the question that they can ask much to sorted list. Okay. Also, why usually interview wants to ask basically they wants to figure out how you think because this problem can be solved with different ways, but they will require a most optimal solution without any space. So we'll discuss all the approaches. Okay, and let's see that. So we have merged two sorted list. You are given the heads of the two sorted linked list, list one and list two. Merge two list into one sorted list. So we need to create one sorted list at the end. And the list should be made by splicing together the nodes of the first two lists. So basically, the list should not be a new space. It should not be a new list. It should be just by splicing, cutting of the next elements and cutting nodes, and then we will form a sorted list. Return the head of the merged linked list. Okay. So you can see here we have 1, 2, 4 as a one list, and we have 1, 3, 4 as a list. And new linked list will be of 1, 1, 2, 3, 4, 4. Okay. And here list 1 is empty, list 2 is empty, and the output is also empty. Okay. So now let's see. So here we have two linked lists. Let me mention this as L1 and this as L2. Okay. And you need to create a new list a bit sorted. Okay, both are sorted here. So how we can do it? Okay, so one of the approach that first that can come to your mind, okay, the brute force one, or I won't say a brute force, more towards an easy approach. Okay, how you can find it very easily. So what you can do? You can create one array, right? You can create one array that is your extra space. Okay, and you can add all the elements like one. Then, so basically you will iterate from it like one. Okay, you will take the temp dot data. Suppose this is pointing to temp. Okay, you will take temp dot data, that is one. You will move your temp pointer. Okay, here. Then you will add 3 and you will move your temp equals to temp dot next, and you will add 5 and then 7. Similarly here you will add all the elements like 2, 3, 3, 4, 8, 9. Right? This will be your complete array by simply traversing through each of the elements. Okay. And now what you will do, you will sort the array. So what we will do, we will create sort, right? So my sorted array will be of 1, then 2, then 3, 3, 3, 4, 5, 7, 8, 9. This will be my new sorted array. Okay. Once I have sorted array, what I can do? Okay. I can create a new list. So you can create a, suppose you can create a new node. Okay. New node with your first element. So I will create one new node simply by writing one simple code of it. Like suppose head. Okay. And that head equals to my new link list node, calling this constructor function with my 0th element. Okay. We'll create a new node that is array of 0. So I will can create with 1. Okay. Once I create this new node, okay, what I will do, I will create one more another node with this pointer, right? So I will basically traverse with I. So I is pointing to 2. I will create one more node with the value of 2. Okay. And I will move my I pointer. So I will create one new node with the value of 3. And I will move my I pointer. Then I will create again one more node with the value of I, that is 3. Again, I will move it. Again, I will create one new node with the array I value. So I will create with 3 and I will move it. Similarly, you will create one more. How do you will move your I pointer here? Okay, you will create one more node with the 4 value and so on. It will simply go till your null. Okay, one of the last point will be 9 and it will point to null, right? This is one of the method that you can try. Okay, apart right here, if you want to like if you want to use your space, okay, so what you can do, you can merge two linked list here L1 and L2. you can simply traverse to the last of L1, which is whichever is smaller, or you can take L2. It doesn't matter literally. So what you can do, you can simply connect L1 with L2, right? This is how you can connect. Sorry, like I am not connected well. I this one. So this is how you simply merge two linked list, because you know the array elements will going to be the basically the complete linked list. Okay, so you merged it, and now what you are doing, you are modifying your values one by one. So you took one element, like suppose L1. Okay, you are modifying with this one, then you are modifying this with two, then you are modifying this with three, then you are modifying with this three and this three, like this one. You are modifying all these values. Okay, so yeah, this approach that you can try. What can be the approach, like what can be the code for it? So basically what we are doing here, if I write a pseudo code for it, so basically pseudo code that I will simply take one an extra space like this array. Okay, and I will simply traverse till temp is not equals to null. So before that, let me initialize temp equals to L1. Okay. Remember the basic conditions, we can add it here, like if L1 is equals to null. Okay, so what we will do, we will simply return L2 because that is sorted, or if L2 is equals to null, we will return L1. Okay, so here temp is pointing to L1, temp is not equals to null. What I will do, I will simply traverse through it. So I will simply push elements array dot push temp dot data, whatever the data is, temp equals to temp dot next. Okay, so this is for your first linked list, yeah, right? This is for your L1. Okay, same thing you will do for L2, complete same thing. Okay, so if I copy this, I will paste it here, because it will be the same thing. The only thing that will come new is your temp will first pointing to L2. Okay, so you will simply run till L2, right? That's till temp is not equals to null. So you will push all the elements in your array. Once you pushed all the elements, okay, you will do array dot sort. Okay, you can use any inbuilt method. Okay, it's totally depends on you. If you want to do an inbuilt method, bubble sort, selection sort, merge sort, okay, it's totally to you. You can do this a minus b, something like this. This the data will be sorted. Now once the data is sorted, you can create a new list. So basically you can simply join the two linked list, right? If I say how you will join it, so you need to traverse to a one linked list, okay, at the end of it, and you can join the two linked list, then you can find, or I will tell you how you can create a new list, okay, one by one, and you can add the element. So suppose you created a one new list, head equals to new node with your first element, that is zeroth element, okay, as we discussed, and you can take one your current pointer that is pointing to the head, okay, and you can run a loop. Basically I am using a for loop because it will simply traverse to an array. So we have already created with zeroth element, so we don't need to take from zero. I will simply say I will run to I equals to n minus 1, okay, until here. What I will do, I will simply say current dot next, which is pointing to head, that is new node. It will be the new node and the array I. Okay. And then what I will do, I will simply say current equals to current dot next. This is how I will move. And in the last, what I will do, whatever you have created head, I will return the head. Right. So this is how it will work. What will be the time complexity of this approach if I go for it? So here I'm running. So suppose this will taking n1 nodes here. This is taking n2 nodes here. Okay, I'm considering n as n1 plus n2. So here this is running for n1 times. This is running for n2 times. Then I'm doing a sort of complete array. So I'm using basically big O of n log n here, n log n. Again, this is also running for big O of n. Okay, so small n only, big O of n. So what will be the time complexity? Let me put it here. What will be the time complexity of it? So big O of n1 plus big O of n2 plus big O of n log n plus big O of n. If I add this, it will be n1 plus n2. That will be big O of n only. And we have big O of n here. So it will be big O of 2n. Big O of 2n, small n. Okay. Plus we have big O of n log n. Okay. And we always take the higher terms, right? So here in if I taking both the things, right, the maximum term time that will take, that will be big O of n log n. Okay. Again, but you can like write this will be your time complexity. Okay. You whatever the maximum of it, right? If it is, I will take the maximum of it. If I simply say, and eventually it will come to as big O of n log n. Okay. Now let's talk about the space complexity. What is the space complexity that I am taking, right? Time complexity is clear that the maximum amount I am can take, that is n log n. Right? Okay. What is the space complexity here then? Then space complexity is you are creating one array space of big O of n. Okay. And then you are taking one extra space for list, right? So you are creating list also. So that is also big O of n. So it will be big O of 2n, which is eventually that is big O of n. Okay. So space complexity here, that is big O of n. Okay. This will be your time and space complexity. And your interview won't be happy by this approach. Why it will? Because first of all, none of the interviewer like these methods where you manipulate with the temp dot data. Okay, it is very very bad, right? If you are explaining these types of approaches to your interviewer, he won't be happy. Okay, but you should always come up with brute force then better than optimal approach. So how you can explain it? You can say that I can explain you the one of the brute force approach one, and then we'll think about the optimal approach, and then you can discuss the optimal approach then. Okay, you can, but you can start it like this. So this will be your time complexity, and we need to optimize it. We need to optimize this one. So how we can eventually, like, we need always in linked list, we are not going to compromise with this space. Space should not be there, right? So in the next thing, we will try to decrease time complexity and space complexity in the next approach. So let's see what we can do in the approach 2. So see, in the last question, in the last approach, we not use the properties of sorting, right? The two lists are sorted, right? This is sorted, and we are not using it. Okay, this is waste of the sorted arrays that is given, the sorted list that is given. Okay, and why we are creating a new space when we have already list provided? Why we are not can return the same list? Okay, so we have L1 this, we have L2 this. We will use the concepts first. We will use the same list, same linked list. Okay, and then we will use the concept of sort, because sorted array, sorted list is given, right? Sorted list is given, so we don't need to sort it again. We will use a two pointers approach to basically merge them, right? By the help of two pointer, we will merge them. So what we will do, what we can do here. So I have one L1 as a list, L2 as a list. I will create a new node. Okay, that is my dummy node. So suppose I have created a new node with 0 value. Okay, and this is my dummy node. Okay, this is my dummy node. I will create one pointer. Let's suppose temp. This is pointing to temp, and this new node, right, that is created, it's pointing to null. Okay, so this is my new node. Now what I will do, I will check one by one L1 and L2 data. So L1 dot data is 1, L2 dot data is 2. Which is less, 1 or 2? 1 is less. So what I will do, I will say temp dot next equals to my L1. I will join this one, right? I will join it completely like this one, that this will be my new list, and this is how I will join it. So basically, I will move this one. Okay. Here I am mentioning the node, but remember, right? This is not a single node. This is a joining of complete list. Okay, a joining of complete list, not a single node. Again, I am telling you. Okay, so I will join it with one, right? I will join with one, and I will move my temp pointer. So my temp pointer will be temp equals to temp dot next. It will point to here. Again, we have the list here, right? Remember, I am not mentioning here, but we have the list. So once I have joined it, I will move my L pointer, right? After just I will, because I have joined with the L1, so I will move my L1 pointer to this. Again, I will discuss the same thing, which is less L1 or L2, L1 data or L2 data, L2 data is less. Now what I will do, I will break the connection. Okay, I will break the connection because this is connected to the list. I will break this connection and I will join with the L2. I will join with the L2, right? I will break this connection. So previously it was joining like this, right? It was joining like this. I will break the connection here and I will join in this, join with this, right? So we won't lose the data because we have a L1 already mentioned, right? So this is how it will work. So what I will do basically, I will create, I will join with 2. So this will be 2 and my temp pointer will again move further, and this is pointing to the again complete list. Once I have joined it, I will move my L2 pointer as well. So my L2 pointer will point to this one. Okay. Now again, I will check which is less, L1 data or L2 data. Both are equal. So I can join with anyone, right? I can join with anyone. So I will join with the L1. So suppose if I'm joining with the L1, it will be 3. Again, remember that this is a complete list. Don't think that I'm joining with the new node. Okay, this is a complete list. I'm joining with the 3. Once I join, my L1 pointer will simply move. So this will move to L1 here. Okay. Again, I will compare L1 and L2, which is small. L2 is small. So what I will do, I will join it with this complete. Okay. I'll join it with this complete. Once I join it, that will be 3. I will move my temp pointer forward. Right. Again, remember that we have a complete list, right? We have a complete list. Once I join it, I will move my L2 pointer as well. So my L2 point into this one. Again, I will compare L1 and L2, which is less. L2 is less. So what I will do, I will again join with the L2. So I will connect this one. What will be the value? That will be the 3. I will move my temp pointer. Okay. And I will move my L2 pointer as well. Okay. Again, I will compare L1 and L2, which is less. So L2 is again less. So what I will do, I will again connect with L2. So basically that is already connected. Okay. In because that's a list. That's a list. Remember, that's a list. So I will simply connect it. This one, simply mention 4. I will move my temp pointer and I will move my L2 pointer. Again, I will check which is less, L1 or L. So here now L1 is less. So now I will break the connection. Now I will break the connection and I will join with my L1. Right. So how I will join it? So I will create it with this one, 5, mention it. Okay. And I will move my pointer. I will move my pointer. Okay, one sec. Once I mention it, what I will do, I will move my L1 pointer as well. I have already moved my temp pointer as well. Again, I will check L1, L2, which is less. L1 is less. So what I will do, I will again mention L1. So let me put it here something. I'll again mention L1. Okay. And I will connect it with this. That is 7. Okay. And I will move my temp pointer and I will move my L1 pointer. Now, once my L1 pointer is null, right? Okay. I will run only when both the pointers. Okay, let me move this aside here or here. Let's see. I will run only when both the pointers should not be null, should not be pointing to null. When both the pointers should be there, should be some value, then I will simply traverse. Once I get the null, can I directly say that the data is already sorted? I will directly join with this one. I will directly join with this one, right? I don't need to traverse it right now. So once I got L1 is null, the next list that is remaining, I'll simply connect it there, right? So what I will do, I will simply join it. So if I join it, this complete, okay, I will simply temp equals to temp. Okay, then there is no need to move. Okay, like L2 is done, temp is also done. Okay, and you have joined it. This will be your required linked list. And what you will return this head. How you will get this head? Remember, we have created dummy node. So I will simply say dummy node dot next. Okay, that will be my head pointer, right? So if I will say simply return, I will return this dummy node not next. This will be my sorted list. So you can see in this list, I'm not creating any new list. I'm using the same list. This is not a new list. I'm using the same list. Basically, what I am doing, I have created one dummy node. Okay, that is starting from 0. It is getting connected from here, then this connected, then this connected. Similarly, we are playing with this one, right? We are simply connecting like this one. So this is how it is working, right? We are not creating a new list. And here we are also not sorting the data. You can see the data is sorted is 1, 2, 3, 3, 3, 4, 5, 7. The data is sorted, but we are not we are not sorting it because we are using the sortedness of the list, right? The lists are already sorted. So we are comparing and we are adding. We are comparing and adding, right? So this is one of the approach that you can apply. What will be the pseudocode for it? So if I write down the code of it, so first of all, like suppose if you are getting L1 is pointing to null, will simply return L2. Okay. Or if L2 is pointing to null, then you will simply return L1. Okay. Once this is done, so what you will do first, you will create a dummy node, creation of a dummy node, creation of dummy node. So how you will create a dummy node? Basically, you can create something like any variable. So suppose I'm creating as dummy equals to my new list node. Basically, that's a class or constructor I'm using. New list load with the value of 0, and I will create one temp variable that will point to dummy. Okay. Once I created, what I will do, I will mention it like while my L1 is not equals to null, not equals to null, and L2 it's not equals to null. Okay, when both are null, when both are not equals to null, and condition, right? And when both are not null, then I will simply add the values. So how I will add the value? Okay, I will simply say if if L1 dot data or val, whatever it is. So in Leetcode you will find it present in the value, that is val. If it is less than equals to your L2 dot val, what I will do, I will simply say temp dot next equals to L1, right? This is my value, and I will simply move my L pointer L1 equals to L1 dot next. Now, like here in this while condition, again in the while condition. So what I will do, I will mention it here because I'm not getting enough space. So this is my while loop that is come till here. Okay. So if this is done, if this condition is not true, okay, maybe your L2 is higher. So what you need to do? What you need to do, you just need to mention temp dot next equals to L2, and you will simply mention L2 equals to L2 dot next. Okay. So this is basically when my while loop is running. If any time suppose L1 got null, okay. So I will write one condition. If suppose L1 is getting null, or if it is not equals to null, that means we have something as in L1. So what I will do, I will simply say temp dot next equals to L1. Okay. Similarly, else case will be there. So I will mention else case here. If suppose, what will be the next case? L2, L1 is null, L2 is not null. That we have already solved. So what I will do, I will simply say temp dot next equals to L2, right? And once this is done, I will return in the last return dummy dot next. So I will return dummy dot next. This is how you will solve the problem. Let's quickly judge the time complexity of it. Okay, what will the time complexity? So you are traversing L1 and L2. Okay, so Okay, here L1 and L2, and then you are simply adding the list. So if I am taking the worst case, the worst case can be that you are simply joining with this, then this, then this, then this, something like this, right? Okay, you are joining. So in this worst case that you need to traverse all N1, N1 plus N2 nodes. Okay, that means total N nodes. So the time complexity of this while loop will be big O of N only, right? Here, this is you are simply adding this, so it won't create any issue on the time complexity. It won't add any effect on the time complexity. So the time complexity here will be big O of N. That's really good, right? Let's take a small N. Okay, that's really good. We have optimized from big of N log N. Okay. And now your space complexity, you are not taking any extra space. You are using the same linked list. So it will be big of one that is constant. So this will be your time and space complexity. And this is how you can solve this problem. Okay. So in the code implementation video, we will see how we can implement this in the code. Okay. So you can check out the next video where I have basically done the implementation part of this one. Okay.